Hello guys. So I got a lot of messages regarding some problem dealing with the retinoscopy related questions. So let's take up one example and try to clear the doubts related to retinoscopy. The question says that on performing the retinoscopy using a plane mirror in a patient who has refractive error of -3 diopter sphere with -2 cylinder at 90 degree from a distance of 1 meter, the reflex will move. Option number A says with the movement in horizontal axis and against the movement in the vertical axis. Option number 2, with the movement in both the axis. Option number 3, against the movement in both the axis, or option number 4 says with the movement in the vertical axis or against the movement in the horizontal axis. Now before we finally reach to the correct option, let's clear up some of the important facts related to retinoscopy. Now these are the different kind of retinoscopes that we have been using. The oldest one was this Lister's reflecting retinoscope. That was a very simple kind of retinoscope. Then we started using this Priestley Smith reflecting retinoscopes. Earlier retinoscopes were kind of a plain mirror that we were using, but nowadays we have been using the most evolved retinoscope, that is your self-illuminating streak retinoscopes. So though they are coming in both spot retinoscope as well as the streak retinoscope. So the spot retinoscope will be showing you round light reflex. We can also use the streak retinoscope where we are using this kind of light reflex. So we are using more commonly this streak retinoscope. So what do you mean by streak retinoscope? Now have you understood? Now what we do, we say that sometimes we have against the movement, sometimes we have with the movement, and sometimes we do not have movement. Now what is the main meaning of this? See, against movement means when you are actually taking the retinoscope in one direction, okay, the reflex seems to move in the opposite direction. So when we do the retinoscopy, okay, so here we are mainly talking about wet retinoscopy. See, there are two kind of retinoscopies. One is dry retinoscopy and another is wet retinoscopy. Dry retinoscopy, when I say dry retinoscopy, this is mainly the undilated retinoscopy, while when I am saying the wet retinoscopy, that is under dilatation, refraction under dilatation. So that means here I am talking about wet retinoscopy after dilating the pupil with the mydriatics and cycloplegics. So pupil is dilated, you are using the retinoscope, you are showing the light reflex inside it. So what is the movement of that light reflex with respect to our retinoscope? Okay, so if they are moving in the opposite direction, so suppose the light reflex is moving in the opposite direction like this, then this is called as against movement. Okay, when the light reflex is moving in the same direction of the retinoscope, then this is called as with motion, while the third is neutral. Neutral means you do not have any movement here, so there is no movement. So when we do actually retinoscopy, there are different interpretations that you can get. Either you won't get any movement, or you get the with movement, or you get the against movement. So what are these different conditions? Suppose I am not getting any movement, okay, so that is called as no movement. Suppose you are not getting any movement, that means that the patient has myopia, and this myopia is exactly equal to 1 diopter. So that is -1 is the refractive error. Then number 2, if the patient is having the with movement. With movement means the movement in the same direction. See, when you are getting same direction, that means the refractive error is going on the lesser power side. So what can be the power lower than -1 diopter? So it can be either the myopia only, which is less than 1 diopter. Okay, then what can be the power even lesser than this? It can be emetropia. So either this patient has emetropia or lower than this also. So lower than this also can be hypermetropia. It can be hypermetropia, and hypermetropia can also lead to the plus movement. So that means if I am getting the with movement, I am not sure whether this patient is having myopia less than 1 diopter, or he is emetropic, or he is hypermetropic. I will have to call for the PMT test, that is called as a post mydriatic test. I will give the retinoscopic findings. I will call the person for the post mydriatic test after the pupil has reached to its normal level. Usually we call after 3 days, okay. So any time when the pupil is normal, we have to call for the PMT, and then we would be sure that actually this patient was having myopia, emetropia or hypermetropia. While the third option, so the third option is that it is going against. So if the -1 was the neutral, so if you are going against it, so that means this patient is having myopia which is more than 1 diopter. So at one level you can understand that this 0 level is -1 diopter myopia. So if you are going against, that means you are going more than -1. If you are coming on the same plane, so it is less than -1 or emetropia, or it can be your hypermetropia. So one thing is very clear, when you are going to get neutral movement, no movement, with movement and against movement, right? Now how to tell? In this question they are asking that what kind of movement the patient will be having. Okay, so what kind of movement the patient is having, for this you cannot tell directly from this. You cannot tell from this refractive error. You have to actually convert it into retinoscopic finding, because they are asking you in different planes, different axes, right? So this means that if they are asking you that what will be the movement in different axes, you will have to first convert this refractive error into retinoscopic finding. So let's see how to do that. So they have written that this patient is having -3 dioptic sphere with -2 diopter cylinder at 90 degree. Okay, this is the refractive error of the patient. Okay, now you have to see that how to convert this into retinoscopic finding. So there is a very easy way of doing this. Okay, we have taken two planes. This is your x-axis and this is your y-axis. This is your horizontal axis and this is your vertical axis, right? Now I am saying that -3 is actually diopter spherical. Spherical means equal in all the meridians. So -3 here also and -3 will be written here also. That is so easy. Now second thing that they are saying that -2 is cylinder, and cylindrical errors are there at a particular plane. So this patient is having this error at 90 degree. This is having at 90 degree. So when you are correcting it at 90 degree, where will this act? This will be acting at a perpendicular plane. So when you give it at a perpendicular plane, so you have edge in the horizontal. So what is the final thing that I am having? Final thing that I am having is -3 here and -5 here. -3 in the vertical plane and -5 in the horizontal plane I am having, right? So this means in two axes I am having different degrees of myopia. One is having myopia equal to 3 and one is having myopia equal to 5. Are you getting this? So you have understood how to convert this into retinoscopic findings. So can you see this is also more than 1 diopter and this is also more than 1 diopter. So this myopia more than 1 diopter will give you against movement, right? And this myopia more than 1 diopter will also give me against movement. So that means what should be my answer? My answer will be against movement. That means my answer will be against movement in both the axes. In both the axes, I will get the against movement. Now let us take one more example. Suppose instead of this, I could have got -3 here and -1 here. Now what is there? -3 is myopia more than 1 diopter and -1 means myopia equal to 1 diopter. So this means that in the y-axis vertical plane, I am going to get the against movement. This will give me against movement, while this is exactly equal to 1 diopter. So this will give me no movement. Are you getting? So different aspects can have different answers. Let us take one more example. Suppose I am having like this and I am having +3 here, okay, and +1 here. +3 and +1. So this is also hypermetropia and this is also hypermetropia, right? Both hypermetropia. So I will get the with movement in both the planes. In both the axes, I will get with. Now let us take one more example. Suppose I am having -1 here and +1 here. Okay. Now don't go into the crucialities. How can this be there? Okay, I am just taking the different examples. This is a case of mixed astigmatism. One is -1 and another is +1. Now when this is exactly equal to -1, that means myopia equal to 1 diopter. So this will give me no movement. So I am going to get no movement here. While this is +1, so this is hypermetropia. When this is hypermetropia, this will give me the with movement. So I can say that in the vertical axis, there will be no movement. In the horizontal axis, there will be with movement. So in this way, you can find out what will be the interpretation of the retinoscopy based on your this retinoscopic findings, whether it is myopia equal to 1 diopter, less than 1 diopter or more than 1 diopter. Clear? Now let us try to learn how to prescribe the glasses, right, and how to get the retinoscopic findings. Okay. So when you want to prescribe the glasses, how do you calculate the retinoscopic findings that time? So for that, you have to do one thing. There you should know that the retinoscopic findings, okay, so you have to first calculate the refractive error from this retinoscopic findings. So if you have the retinoscopic findings, you have told that what kind of movement you are going to take. But if I want to know that what is the exact number for the spectacle prescription of a glasses I have to give, so for that I have to calculate the refractive error in the patient. So refractive error is actually equal to whatever are your retinoscopic findings. So now you already know how to get this retinoscopic findings, okay. Minus, you have to do the distance factor, and then you have to subtract the tonus also from it. Retinoscopic findings minus the distance factor and minus the tonus, then you will get the refractive error. For example, if you take this example, you were having -3 dioptric spherical and -2 diopter cylinder, that was at 90 degree. Okay, so how to get the retinoscopic findings that I told you? So you were having -3 here and -5 here, right? Now how to get the refractive error? So you have to subtract the distance factor. So distance factor is 1 upon the distance which is given in the meters. 1 upon the distance which is given in the meters is actually your distance factor, and tonus. Now this tonus can be different for the different drugs. So always remember ACH, you know, acetylcholine ACH, it is 1, 0.75 and 0.5. So we have got the tonus alliance for the different drugs. Okay, now let us take this example only where they have done this retinoscopy from a distance of 1 meter. Okay, and to make our calculation simpler, let us take that we have used atropine here. Okay, so how to get the refractive error here? I will have to reduce this distance factor and this tonus from the retinoscopic findings. So what is the distance factor? -1. And what is the tonus? -1. Similarly here, what is the distance? -1. And what is the tonus? Again -1. So what are you going to get finally? Finally, what you are going to get? You are going to get here, okay. Now because these are minus, so they will add up here. So they will become here -5, and what you are going to get here? This is your -7. So this will be your final refractive error. But instead of this, suppose you are having the plus findings. Suppose you are having +3 and +5. Now, if you are having this retinoscopic findings and if I calculate the refractive error, what will happen? -1, that is your distance, and -1, that is your tonus. Similarly, here also -1, this is your distance, and -1 is your tonus. So, what you are going to get finally? So, they will be subtracting now. So, I will get only +1 here and I am going to get +3 here. Okay, now we will learn how to prescribe the glasses. How to prescribe glasses. Suppose person is having this retinoscopic findings, we have calculated the refractive error also, and now we have to see that what is the prescription of the glasses that I can give. So there are certain steps that you have to follow. What is your step number 1? The step number 1 is that you have to take 1 as your spherical error. Okay, take 1 as your spherical error. So suppose I take this as your spherical error plus 1 diopter sphere. Okay, so other will become, suppose I am saying that this is my spherical error. So other will become cylindrical error. So this is your cylindrical. So +1 I have given as diopter spherical. That means the moment you give +1 as diopter spherical, this +1 has started acting here also and here also. But actually here I have to give just +3. So I will have to subtract the spherical correction from the cylindrical correction. So this will give me plus 3 minus 1. I have to subtract. What is this? This is your sphere. This is your spherical correction, okay, and this is your cylinder minus sphere, because sphere we have already given there, so I will have to subtract it, okay. Now this is your step number 2. So that means I will have to give plus 1 diopter spherical and I will have to give plus 2 diopter cylinder. I have got these values, right? So this is your step number 2. I have got the values. Now step number 3. What should be my step number 3? Step number 3 is the axis. Step number 3 is axis. Now because you want to give this plus 3 at 180 degrees, cylindrical correction has to be given at 180. So that means you have to give it at perpendicular plane, because you know the value of the cylinder, the power of the cylinders always act at a perpendicular plane. So if I give at 180, it will act at 90. So I want it to act at 180, I will have to give it at 90. So that means my step number 3 will be that plus 1 diopter spherical with plus 2 diopter cylinder, and this has to be given at 90 degree. So when you give it at 90 degree, this will act at 180 degree. So one of the spectacle prescription can be this person can be given this spectacle correction. Are you getting this? We have done this. Now what is the other method? Suppose this was your there, plus 1 here and plus 3 here, right? Now suppose instead of this I have chosen this as the spherical correction, then what would happen? Then this will give me plus 3 diopter spherical and plus 1 diopter cylinder. This is your step number 1. This has chosen as the diopter spherical, so this becomes diopter cylinder, step number 1. Now what should be my step number 2? Step number 2 says that if I have chosen plus 3 diopter spherical, so this is already acting at both the planes, while here I require just plus 1, so I will have to subtract it. Plus 1 minus 3, I will have to subtract this minus 3 because I have already given plus 3 and I require only plus 1 here. So now this will become my diopter spherical correction and this will become my diopter cylindrical correction, plus 1 minus 3. So this will give me plus 3 diopter spherical with what is this? Minus 2 diopter cylinder, minus 2 diopter cylinder. Now what should be my step number 3? Step number 3 is that I have to give it at 90. So obviously I will have to give it at 180 because I want to give it at 90 degree. So I will give it a perpendicular plane. So this minus 2, therefore I have to give at plus 3 diopter spherical with minus 2 diopter cylinder at 180 degree. So my second spectacle prescription that I can give for the same is this one. So 3 things you have learnt today. First of all, how to interpret the retinoscopic findings, the no movement, with movement and against movement. Number 2, you have learned how to calculate the refractive error. So if you are getting any question related to the interpretation of retinoscopy, if you are getting any question how to calculate the refractive error, and number 3, the prescription of the glasses. Now there is one more thing how they can ask you. Suppose they have given you to calculate the refractive error. Okay, suppose they have given you to calculate the refractive error, they can also ask you the type of astigmatism. They can also ask you the type of astigmatism, like we solved a question related to astigmatism. What is the kind of astigmatism we have? So let us try to see that also. How can we do it? Suppose the patient is coming, in this question what they have given, minus 3 diopter spherical with minus 2 diopter cylinder at 90 degree they have said. So how to calculate the refractive error and the type of astigmatism. So what will happen if you convert this into retinoscopic finding? Diopter spherical will be acting in both the planes, while -2 they are giving at 90 degree. So where it will act? It will act in the horizontal plane. Okay, so this means now I am getting -3 here and -5 here, -3 here and -5 here. Now if you calculate the refractive error, so if I take the same findings, -1 here and the -1 here, and then again what you are taking? -1 for the atropine and -1 for the atropine here. So totally you are going to get -5 and -7. Now can you tell me the type of astigmatism? What is the type of astigmatism here? -5 and -7. Is this astigmatism? Yes, this is astigmatism. Why? Because you have got different power. Now none of the meridian is emmetropic, so this is not a simple astigmatism, this is a compound astigmatism. Okay, and you know, more the myopia, more is the power. So -7 is more than -5. -7 is more than -5. So this is actually against the rule. This is your against the rule astigmatism. So I hope this is very clear that how you calculate the refractive error, the astigmatism, how can you give the spectacles and find out the interpretations. In case of any doubt, you people can always ping me up in any of these social media platforms. I will be more than happy to help you in any way that I can, and please do write to me what are your feedbacks about these videos, how they are helping you, and also suggest what are the new things and the other videos that I can make for you and help you in any way. Thank you and happy ophthalmology.